For 100 years, cars were machines defined by mechanical mastery. Thousands of moving parts, tight tolerances, decades of refinement. But electric cars flipped that definition. Electric motor has about 20 moving parts. No explosions, no gearbox gymnastics, no mechanical magic.
Over the last couple of years, the German industry lost tremendous market share, and the Chinese manufacturers not only stay in China, they come over to Europe. And these two developments simultaneously put a lot of pressure on the German automotive industry.
By around 2010, the internal combustion engine had stopped getting better. A 10-year-old gas car doesn't feel obsolete. It offers the same real-world utility as a new one. Similar range, the same 5-minute refill, and nearly identical reliability. Once the technology plateaued, cars stopped getting meaningfully better. And when progress slows, opportunities open. That opening is what Martin Eberhard and Mark Tarpenning saw when they founded Tesla. The first Tesla Roadster was designed to be simple. Chassis came from Lotus. The battery was built from existing lithium-ion cells. By removing the engine, the most complex part of the car, they proved something radical. Suddenly, the hardest part of building a car wasn't a mechanical engineering anymore. It was software, batteries, power management. And that shift matters because machines and devices evolve very differently. Electric cars depreciate faster than gas cars. On average, a car loses about 45% of its value in 5 years. For EVs, that number is closer to 60%. That gap isn't about quality, it's about pace. Take the Nissan Leaf. When it launched, it was the most successful electric car in the world. For nearly a decade, up until 2020, it was best-selling EV in the world. But battery technology didn't slow down. Early Leafs had small 24-kilowatt batteries, no active cooling, slow charging, and rapid degradation. Compared to modern EVs, battery density increased, charging speeds jumped, battery architectures doubled, from 400 to 800 volts. Legacy automakers, long masters of the internal combustion engine, suddenly had to catch up. Now, a new wave is accelerating the shift even faster. Xiaomi isn't a car company. They're a phone company. Yet in just a few years, they built the SU7. It matches, and in some cases beats, Porsche and Tesla for performance, at a fraction of the price. China isn't just backing its automakers. They're building a global strategy. They also control key natural resources, lithium, cobalt, and nickel, critical for batteries. And Western governments have noticed. To protect domestic automakers, US has imposed a massive 100% tariff on Chinese electric cars. In the short term, tariffs shield local companies and jobs. Even the best EVs are still tied to the technology of their generation. Most EVs on the road today run on 400-volt systems. It works, but the industry is already moving to 800 volts, cutting charging times in half. Newer chemistries like LFP are safer and cheaper. The world's largest EV maker, BYD, is now rolling LFP across its entire fleet. On the horizon, solid-state batteries promise higher density and longer lifespans. Used electric cars lose value faster than gas cars, not because they are unreliable, but because technology just keeps leaping ahead. And that rapid evolution, it's exactly what makes EV revolution so powerful.